Today I'm going to show you how to make good construction on a part like this, a motor shaft with the adjustment spring and the locking ring. And the benefit will be if you change, let me just fit here everything. If you change the diameter of the cylinder, everything goes with it. So let's start on this. Oh, I will show you. No, let's start on this with a new file. Get a new file on part design and make a block. And I will enable the origins here. And if it's a ladder tool, a ladder part with rotation symmetry, it's best to start on the XZ plane. Of course, the machine that produces the part has this plane set up. So it's a rotation part, so let's start first with an axis to indicate it's a rotation part. The video is mainly for our students, but it's always best to follow good construction. So let's do this plane, the main plane we're using, and saying just get an axis in. The axis is fine on the X level. Here X of the object, and that's it in first place. So let's draw our first sketch. Here's the main reference plane to be in the X direction. Let's use this. If you have a double side shaft, you may use a new plane with a distance to the other side. So I go here, start in the middle, go up using the grid. The grid you can enable in the grid in the settings on the sideway here, settings, and or disable it if you don't need it. So let's get the measurements in. The main wide will be 60 millimeters. The front side will be 30 millimeters, and we have this one here on 30 millimeters. Why didn't it take it? Here we go. So half 15, and the complete diameter is 50 millimeters, so 25 and a half. So this should be it, but there is no 30 millimeter inside here. 30. Okay, now it's all green, and we are finished with our first sketch. So now you can just rotate it. You see, oh, that's not what we want. We can use here the x-axis, but we can also use our reference date plane, date line. So to use the main system, it's always the best to get all references in and don't use the system internals. So next would be, as we need some transparency, it's always good here, get the body, and with the viewing here I set 50%. Now we're gonna make our adjustment spring first. Here we need it on parallel to or aligned to the cylinder. How do we do that? We simply select the face here. If all is enabled, it's sometimes difficult to select the right thing. and I will select this one. Here it goes straight through the middle, and here you say it says tangent to the cylinder with a node. A node, where's our node? Our node is this line here. This line has an end vertex. I will select this and will try to get here the point. There's a point, and if I select this, it's aligned to the top of the cylinder. Here you see it's aligned to the cylinder. If we change the diameter, this will move up and everything will move with it. So we use this plane we now have, reference plane, and make a sketch. You can select the plane, or you can just nothing select and say sketcher, and here's the plane is ready to use. So here we are. Make our sketch. I hit escape to get out of the sketcher, and now I will first have the diameter in the books. You can read on the measurements. Here we use 8 millimeter. We use a length of 10 millimeters, and we use, as we need a locking ring here, we use a distance of 4 millimeters. Oh, not 4, that's 8 millimeters. 4 is the distance. 4 plus 4 is 8. Should work. I think we can get 10, even 9. Let's go with that. No, we need a little more, so 10 millimeters. There's a German norm on it that says the distance to the edges. You can look in the books, but it's also clear there. And in the books is also here with the depth here, it's 4 millimeters on an 8 millimeter thing. This will follow our plane. So that's it for the first thing, and now we're gonna I enable the sketch. Of course we use it here. We're gonna make now our locking ring. So let's select X set plane and make a sketch on that one. Get in our square of the ring. It's 1.5 millimeters in the thickness, and the depth is 0.8. So if we change the diameter, always this measurement will stay. So now we can't select here our plane we just did. What do? We need a measurement here. We can't measure to the center because then it won't follow. So we need to measure against our sketch we already have. Therefore FreeCAD has a good ability here. Just turn on to the behavior, here the blue lines, and here's a button that says copy of geometry. So I select that one here, and all the measurements from the first sketch come into view. We just need one line, so we can escape or delete here the other lines. You will see the measurements go off if you use it here. Okay, so that one goes off too, and I also can delete this one. Now I have the 50 millimeters I just want to use, and that's the point we need. Now I'll go select this one, select the middle point, and say height 0, so we have it on the plane, and this should be it. There's one thing left. Here it says 0.8, 1.5. Did we miss one line here? I don't think we missed one. Let's see if it works on that. Get a rotation groove. Works. So, and select our axis we just made. Okay, and there we got it into. That's what we want to see. And as always, I will get all these lines off here. No groove we need. And as always, the last thing is the good viewing things. The things we need always here. Just make a corner in here. Make a radius in, okay, make a radius in here, let's say 2 millimeters, and we got the finished part. So that's not, I just want to see it to show you as it works as we should like. I will get to full view, and let's enable, I will enter one more plane here. So we got 30 millimeters, we make a plane in distance on the z-axis 15, and this goes to 0. So okay, now I'm gonna delete all beyond this. You see here it's aligned on 15 millimeters. We do not need this plane, it's just for viewing. And now I will go to the first sketch. I will double click on it and we'll change the 15 millimeters to 14, and we'll say OK. And now you see everything has moved down there. There's still 0.8 millimeters here in the z-axis, the distance, and there's still 4 millimeters inside here. There's no point, or if there would be a point, I could show you a measurement of the depth, but it's also there. If I select the plane, let's unselect this one, and if I select the plane and say measure, linear measurement of the plane, and say right, so let's see if there's a measurement down there. No, there is nothing. All is selected. No. Okay, you get the point. Sorry, I can't measure it now, the distance. So there's a point, and there should be also a point up down there, and it would make a distance 3.42 millimeters. Now I would like to see the distance in total, but it's not there. Okay, you get the point. I want to show you it follows the lines. If the plane changes or the diameter change, everything measured to this value will change. So get this done, get rid of the measurement, and see you next time.